Dr. J. Raja Paul Perimbam, Professor of ECE, KCG College of Technology, Chennai. He has completed his BE Electrical Engineering from Madras University and has done his MSc Engineering in Applied Electronics. He has also completed his PhD in IIT Madras. He has specialized in electronic circuits, microprocessor and embedded system, power electronics and VLSI design. He has over 32 years of teaching experience in Anna University, Chennai. He had worked as a professor of ECE and head of the Department of Media Science in College of Engineering, Guindy. He has guided 16 research scholars. He has also participated in 12 international and 3 national conferences. He has published 31 international journals and 5 national journals.
Welcome to UGC lecture series. We are seeing about the Microprocessor I. So, last lecture class we completed the architecture of the 8085 microprocessor, and then we started with an introduction to the 8085 instruction. So, we will now continue with that. 8085 instructions are to be given in the form of a binary number, that is 8-bit binary number. So, a 8-bit binary number can have 256 combination. Therefore, we can have 256 instruction, but 8085 uses only 246 of the 256 combinations. Okay. So, it has got actually 74 instructions, and then combinations of these instructions work out to 246. Instruction means move is an instruction. Okay. Combination of move is move A comma B. We can have other combination as move A comma C, and then another combination move C comma A, move D comma E, and like that for every instruction we can have several combinations. So, basic instructions are 74, and then combinations of the instructions are all put together, it works out to 246. Yeah. So, to study the instructions in a easier manner, the instructions are grouped as data transfer instructions for data transfer operation, and then instructions for arithmetic operation, and next instruction for logic operation, and instruction for branch operation, and machine control operation instructions. Okay. So, we will see these instructions one by one. Okay. So, first we will see about the data transfer instructions. So, what is data transfer? So, the data transfer, what it does is, these instruction what does is, they simply copy the data from one location to another location. So, you have a source location and you have a destination location. So, it copies the data from a source to a destination. So, what are the source and what are the destination we will see. So, some of the data transfer instruction I have mentioned here. So, these are called as mnemonic. So, move immediate. So, move is in shorthand form is represented as MOV, and move immediate again in shorthand form it is represented as MVI. So, these are called as mnemonics. Then load accumulator and store accumulator. So, these are some of the data transfer instructions. Okay. So, what are the source and destination? Okay. So, the data is transferred between one register to another register. So, we have registers A, B, C, D, E and so on. Between these registers the data can be transferred. Then the data can be transferred between register and memory location. So, 8085 can address 64,000 memory location. So, from any location, any memory location to any register, or from any register to any memory location, it can be transferred. So, it can be transferred from memory location to register and register to memory location, and the data also can be transferred from input output device to the accumulator, and also from accumulator to the input output device. So, when you transfer data, you are transferring it from a source to a destination. The source data will not be affected. Okay. So, only in the destination if some other data is there, so that will be overwritten, and whatever that is in the source will not be changed. Okay. It will not be affected. That is very important, you have to remember. Now, let us see few examples of the data transfer instructions. Okay. So, operation and then instruction. So, what operation you want to do? So, you want to load a 8-bit number So, which is this number, let us for example, let us take 4f, this is a binary number represented in hexadecimal form. So, 8 bit number in register B. So, you have to put this number in register B. So, what is the instruction? So, the instruction for doing this operation is move immediate B comma 4FH, MVI, that is the shorthand form of move immediate. So, move immediate B means immediate data. So, the data follows immediately the instruction, and then this operand that has to be operated by the instruction. So, this instruction followed by the operand. Okay. So, the immediately following operand is move to register B. So, this is one example. Then next example. So, you want to copy the contents of register B to the register A. So, what is the instruction? So, this is the instruction for that. Okay. So, you have to read it in this direction. So, the content of B is copied to register A. Okay. So, from B it goes to A. So, in this direction you have to read. So, this is one another instruction. So, you can also load 16 bit numbers also, that is 2 byte number also. So, for loading 16 bit number you require 2 registers, that is a pair of register, H register and L register. Okay. So, you want to load a 16 bit number 2050, okay, 2 registers, that is a register pair H and L. So, this is the instruction for that LXI. X means extended, extended means from 8 bit it is extended to 16 bit, LXI H. So, H represents actually H and L. So, this will go to H and then this will go to L. Okay. So, then another instruction, another example. Okay. You want to copy the contents of register to a memory, and then the address of the memory is given like this. So, this is the address of the memory, in of course, it is in hexadecimal number. Okay. So, you want to copy what are the contents in the register to this memory location, the address is given here. So, what is the instruction? So, move M comma B. Okay. So, M represents the address of this memory location. So, this memory location address has to be loaded previously in the register pair H and L. So, when you give this instruction, okay, so this will automatically copy, this address is already loaded here. If it is already loaded here, then the contents of B will be copied to the memory location of address 2050H. Then you want to send data to the input or output port. So, the data from the accumulator can be sent to an output port, and data from the input port can be brought into the accumulator. So, this is the instruction. So, if you want to send the data that is there in the accumulator to an output port number 01. So, out 01, this is the port number, you have to mention the port number, of course, in binary form, of course, here in a shorthand binary form, that is the hexadecimal form. So, you want to read the contents of the input port 07 number, input port number is 07, then the contents of the input port will go to the accumulator, that is it will go to the accumulator. So, in 07H. So, these are some of the instructions. So, then there are other type of data transfer instruction also, let us see that. So, you can have data transfer, 16 bit data transfer also. Okay. So, the 16 bit data transfer can be done again by using this instruction LXI. Okay. So, although the 8085 is a 8 bit microprocessor, so it provides few instructions for handling 16 bit numbers also. So, one of the instruction is the data transfer instruction for 16 bit numbers, that is the LXI instruction. So, the explanation for LXI. So, L load, X means extended and then immediate. So, the immediate 16 bit number following this instruction will be loaded into the register pair. Okay. Extended means 8 bit is extended to 16. So, you have to mention the name of the register pair. Register pair can be HL or BC or DE. So, HL means we will put H only, BC means we will put B only, and DE means we will put D only. Okay. So, for example, this is one example LXI B 400H. Okay. So, this B represents 2 registers. Okay. So, although we have put only B, when it is extended data transfer, it automatically implies 2 registers are involved. Okay. So, you have to transfer 2 bytes. So, this is 1 byte 40, this is another byte. Okay. So, this upper 4, so upper byte and lower byte. So, the upper 4 byte will be go to B register and lower 4 byte upper byte will go to B register and then this lower byte will go to C register. Okay. So, you can see here LXI B 400H. Okay. So, this is the upper byte and then lower byte. So, this after the execution of this instruction, this 40 will go to B register and then 00 this will go to C register. Okay. So, this is the LXI instruction. Then of course, you can transfer data to the memory also. Okay. So, memory also can be treated like a register and then you can transfer data from memory to register or register to memory. So, in that case you have to mention the location address of the memory. So, you have to mention the address of the memory or the location number of the memory. Okay. So, we use the symbol M to represent memory. So, M means it is a memory operation. So, for example, move M comma B means, so the data has to go to the memory. Okay. So, this M, so instead of M if there is some C, B, D, E then it is a register. Okay. So, M means it is always memory. Okay. So, the copy the data from, so what it does, it copies the data from the register B to the memory location. Okay. So, then I am saying simply memory location, which memory location. Okay. So, memory location can be from 0 to 64,000 anything. Okay. So, you have to exactly specify the number. Okay. How to specify the memory location? Okay. So, the memory location you have to preload in the HL register pair before you execute this instruction, before you write the instruction you should using the data transfer instruction. So, you have to preload the address of the memory in the HL register pair, after that only you should give this instruction. So, the memory location is identified by the contents of the HL register pair. So, whatever memory location you want to transfer the data, so that location number has to be put in HL register pair and then this instruction should be executed. Okay. So, the 16-bit contents of that HL register pair will be treated as the address. So, the whatever contents you have loaded in that 16-bit register H and L put together will be treated as the memory location and then memory address, and the contents of the B register will go to that memory number. Okay. Then you can transfer the data between this also provides a data transfer between pair of registers. Pair of register means 16-bit numbers together. Okay. For example, okay, load accumulator extended. Okay. So, you can load the HL register pair using this pair of register by using this instruction. Okay. So, the copy the 8-bit contents of the memory location identified by the register pair into the accumulator. Okay. So, the any memory address can be identified by loading the address into any one of the pair of the register, that is you can use B and C or D and D or H and L. Okay. So, this instruction will use B and C and D and D. So, previous instruction use H and L. Okay. So, previous instruction what we saw. Okay. So, this instruction, okay, it uses H and L. Okay. So, this load instruction it uses B, B, C, the pair of register B and C, and then another the other pair D and D. Okay. So, it will not use H and L register. Let us see briefly what is indirect addressing mode. Okay. So, what is the definition for indirect addressing mode? That is using the memory directly without loading that into the microprocessor. This is called as the indirect addressing mode. So, the indirect addressing mode uses the data that is there in the register pair. So, the 16-bit address is loaded into the register pair and that serves as the address of the pointer to the memory location. Okay. So, in this case H and L register is the one that is used for pointing to the memory location. So, this is called as the indirect addressing mode. So, let us have now a brief break and meet again. Welcome back. So, we are seeing about what is meant by indirect addressing mode. So, we do not in the indirect addressing mode, we do not explicitly mention the address of the memory in the instruction. So, the address where the data has to go should be preloaded into any one of the register pairs. So, we have register pairs BC, DE and then HL. So, this will be preloaded into any one of the register, and we simply use an instruction, and the instruction will automatically take the contents of the any one of the register pair depending upon what instruction we give, and then the data will be transferred to the address that is pointed to by the 16-bit number that is stored in any one of the register pair. Okay. So, we can use HL register pair, okay, as a pointer. So, we can load the address into HL register pair. So, the HL register pair will point to can be made to point any of the memory location, okay, 0 to 64,000 we have. Okay. So, any of the memory location it can point, and the data from that memory location can be moved to any register. Okay. So, that is pointed the memory location that is pointed to by the address that is preloaded into the HL register. From that address the data can be moved to any of the register, or from the any of the register it can be moved to again to the memory location that is pointed to by the HL register. And you can also use BC register pair BC and then the DE also as pointers to the memory location, but these register can move data between accumulator only, okay, from accumulator and memory only. Okay. So, this HL pair can be used for moving data from any memory location to any register, but this BC and DE it moves the data from memory to accumulator from accumulator to memory. Now, let us see the other type of instruction. So, we saw just now the data transfer instructions. Now, let us see about the arithmetic instructions. So, what are the arithmetic operations that can be done? So, the 8085 is capable of adding 8-bit numbers, and you can also subtract 8-bit number, and then you can also increment or decrement. So, the contents of the accumulator or any register can be incremented by 1 or decremented by 1. Okay. So, let us see few examples. Okay. So, what we want to, so this is the operation we want to do, and what instructions we have to give. Okay. So, we want to add a 8-bit number, let us say the 8-bit binary number is of course represented in hexadecimal form is 32H. This number you want to add it to the accumulator, and after addition the result will be there in the accumulator for all the arithmetic instruction. Okay. After the arithmetic operation the result will be stored in the accumulator. Okay. So, this is the instruction. So, A means AD means add. So, ADD the shorthand form mnemonics add, then I is immediate. So, the instruction data is immediately follows this instruction, this the data H2. So, this data will be added to this binary number will be added to the contents of the accumulator, and the result will be there in the accumulator. So, you can add any register to the accumulator, contents of the register B can be added to the accumulator, and then of course, the result also will be there in the accumulator. Okay. So, this is the instruction add B, and you can also subtract any number from the accumulator. So, the immediate number 32H has to be subtracted from the accumulator. So, what is the instruction? Subtract is SU, it is the shorthand form of subtraction, so I immediate, okay, 32H. Okay, this is the number we want to subtract, and you can also subtract from the accumulator the contents of any register. So, you want to subtract the contents of the register from the contents of the accumulator. So, that is subtract C. So, you need not mention A, because it is implied that all arithmetic operation has to be one of the operator has to be an accumulator, and the result will also be there in accumulator only. So, result will be there in accumulator only. Okay. And you increment the contents of the register D, okay, or any register B, C or whatever it may be. So, the instruction is INR. INR increment shorthand form is INR D. Okay. So, the contents of the, suppose if it contains 5, D register contains 5, after the instruction it will contain 6. Okay. So, you can also decrement a register, you want to decrement the register E, then this is the instruction decrement E. Okay. So, these are the some of the examples of the arithmetic operation. Okay. So, let us see in more detail some of the arithmetic operations. So, you can I told that you can add the number. So, you can add any immediate number. Okay. So, any you can after the add instruction you can put the your number immediately after the instruction, or the addition can be done between register and then the accumulator, and also you can do the addition from memory location. One of the data can be in the memory location, and then the of course other data has to be the contents of the accumulator. So, you can add the contents of the memory location to the contents of the accumulator. So, the instructions of course add immediate. Okay. So, the result, so this is important, the result is always stored in the accumulator. Okay. So, it has to be this addition has to be done with the contents of the accumulator, and then the result will be there in the accumulator only. Okay. Then similarly subtract instruction. Okay. Subtract can have SUB, that means any register or memory location or any immediate data. So, you can again any immediate. So, after the opcode any immediate number 8-bit number following the opcode that can be subtracted, and or contents of register or contents of memory location. Okay. So, again the subtraction has to be done, the other number has to be in, when you subtract two number, one number has to be the accumulator in the accumulator, and then again the result will be in accumulator only. Okay. So, the result is stored in the accumulator. Okay. Then the let us see the instruction for arithmetic operation related to arithmetic operation, of course related to the memory. Okay. So, in this case, so one of the data will be there in the memory, for example, add m. Okay. So, m means memory. Okay. So, this one the data will be in the memory. So, which memory location? So, the memory location will be the location pointed by the HL register pair. So, you have to preload the memory location to the HL register pair. So, the location pointed to by the HL register pair, from that location the data that is stored in the location will be taken, and that will be added to the contents of the accumulator, and it will be again of course, the result will be stored in the accumulator. Okay. So, similarly same way we can also increment decrement m. M means of course, memory location. Okay. So, how to identify the memory location? So, you have to use the contents of the HL register to identify the memory location. So, if you want to increment the contents of the memory location, say 1500H hexadecimal number 1500H, then you have to preload 1500H to HL register pair. After loading the HL register pair, of course, by using the data transfer instruction, then only you have to give the instruction, give the any of these instructions. Okay. This is very important. Of course, all these things we will see when you see about the many programming examples. Okay. Then of course, again seeing about the increment and decrement detail instruction in more detail. Again you can increment and decrement the contents of the memory location also. Okay. So, automatically the contents of the memory location will be data that is there in the memory location will be incremented and decremented, and then of course, the contents of the accumulator will not be affected. Okay. Suppose the number 5 is stored in memory location, okay, say memory location 1400H. So, after you give the increment memory, of course, you have to preload the memory address, correct memory address in the HL register. So, the contents of that location, if it is 5, it will be incremented to 6, and of course, the contents of the accumulator will not be disturbed. Okay. Contents of the accumulator will not be disturbed. Then of course, you can also manipulate the register pair. So, I have reproduced the architecture of the 8085 for your reference. Okay. So, just to have a few minutes review. So, it has accumulator flag, and then register pairs BC is one register pair, okay, and then DE is another register pair, and HL is another register pair. Okay. So, these register pairs also can be treated as a 16-bit number, okay, and it can be incremented or decremented. So, instead of treating them as 8-bit number, so both can be taken as a single 16-bit number and it can be incremented or decremented. Okay. So, therefore, it is possible to manipulate this register pair as a 16-bit number. Okay. Contents of this can be treated as a single 16-bit number and they can be incremented or decremented. So, the instruction to treat them as a 16-bit number and then increment or decrement is in x. So, in is increment, okay. X means extended, okay. Extended means these contents of D and E or H and L or B and C are treated as a single 16-bit number, okay. So, RP means it represents any one of the register pair, either B and C, D and E or H and L, okay. Similarly, you can also decrement it, treating them as a single 16-bit register, okay. You can decrement it, okay. So, then of course, let us see about a few special arithmetic instructions. One is decimal adjust accumulator. So, this is a very important instruction which is used for BCD number addition and then subtraction. So, this as you all are aware, that is BCD number means the decimal number, okay. So, the decimal this so 85 is a decimal number. So, 85 can be written as 5 can be written as in the binary form and then 8 can be written as in binary form, and that is called as the BCD number notation, okay. So, instead of converting 85 divide, so I hope you know about the conversion of the decimal to binary, okay. So, if you are given a any decimal number, okay, you can keep on dividing by 2 and then you can write it in the binary form, okay. So, for example, 85 means you divide by 2, again divide by 2, divide 2. So, that is the procedure which would I hope you should be aware of that, okay. So, instead of doing that, so 85 can be written as so 5 means 0 1 0 and then 8 1 0 0 0. So, 85 can be written as 1 0 0 0 and then 5 can be written as 0 1 0. So, this is called as the BCD notation, okay. So, you can load any number from 0 to 99 in a register, okay. So, when you use this notation and then do some addition and subtraction, there will be error. So, to correct the error, so this DAA instruction is used, okay. Now, let us see the summary of what we have seen. So, we saw about the instruction sets and how they are classified. So, we saw in detail the following types of instruction sets, that is the data transfer instruction and then the instructions for arithmetic operations, okay. Now, I will give few questions for you to find the answer. So, the question number 1, of course, mention the various types of data transfer instructions. Then question number 2, write the instructions to transfer the contents of register C to the memory location 40 EEH. Question number 3, write the instructions for incrementing a 16-bit binary number stored in 8085 registers. So, in the next class we will see about the other types of instructions. Thank you.